We're going to work through our 8.3, 1 to 15 odd questions. The first several questions we are supposed to graph. So I just reminded us here of how we do this. First, we start by graphing 3 very important points. We can graph a few more if we need to. So I'll kind of put others if it helps. And we have to know that the x-axis is a horizontal asymptote. And also remember, this is for the parent function. We might have to move things if necessary. Move them up or down or left or right or flip them over. So here we go. Number 1, y equals 2 to the x. Well, we want to graph the point 0, 1, 0, 1, 1, the base. So we're going to graph 0, 1, 1, the base. The base is 2 here, and then negative 1, the reciprocal of the base. The reciprocal of 2 is 1/2. So my graph got a little bit off here on the grid in the background, but we can figure it out. 1, 2 over 1 up 2. And then negative 1, 1/2. Negative 1, 1/2 is about right there. And our graph will look like this. We could do some other points. We could think if we put a 2 in here, 2 squared is 4, which would be about there. Put a 3 in there, 2 cubed is 8. And so this would be our exponential function. All right, number 3. Well, this is a little bit interesting because we had 2 and now we're going to do a half, which is reciprocal of 2. So we have our few points here. We have the point 0, 1, 1, the base, which is 1/2, and negative 1, the reciprocal of the base. Reciprocal of 1/2 is 2. So we'll graph these 3 points. So we have 0, 1, 1, 1/2. So this is actually below, and then negative 1, 2. If we kept going, negative 2, we would have 4 because, let's just do a quick explanation of this. This is like 1 over negative, or 1 to the negative 2 over 2 to the negative 2. Well, we learned that negative exponents, if something's in the numerator, it moves to the denominator, and the exponent becomes positive. It's in the denominator, it moves to the numerator, and the exponent becomes positive. So this is just 4. And so then we can graph it. We know that the x-axis is a horizontal asymptote. And we actually see 1 and 3 are kind of mirrors of each other over the y-axis. Number 5. All right, number 5 is a little different because it has a negative out front. So we're going to start by graphing the parent function. But then what do we do when we have a negative out front? Well, we flip it over the x-axis. So we flip it kind of vertically. All right. So the parent function, we have our points are 0, 1. So our parent function is just y equals 3 to the x without the negative. And we have 1 comma the base and negative 1 the reciprocal. So 0, 1, 1, 3, negative 1, 1/3. And we could get a couple other points in there if we had a negative. So this is just another helpful point, negative 2, 1/9. Sorry, well, that's on there. That's not the one I was referring to. I wanted to put 2, comma 9. So 2, 9. Would be about there. And so then we can draw that graph. but this is not the graph. This is not our final answer graph. That's the parent function. Well, this negative means we flip it over the x-axis. So we're going to flip each of these. So we just go on the opposite side of the x-axis. And we get the function that we want. So let's put our answer in green here. So the negative flipped it for us. Well, number 7 is going to be similar. In fact, if you look up at number 1, we already did 2 to the x. Negative 2 to the x is just going to be that one flipped over. So we can take the points from this and we can flip it. So we could start by graphing y equals 2 to the x and then flip, but we already have it. So this point's going to go to -1, -half, -2, and -4. So there is that graph. This point is not supposed to be in here. And so there's the graph of y equals -2 to the x. And once again, number 9, the parent function is up here in number 1. So what are we going to do here? Well, there's a 1 added inside the exponent, so this is going to move left 1. So we would take all of our points and move them left 1. And so this point here, it's going to go left 1. The point 0, 1 will go left 1 to -1, 1. And the point 1, 2 will go left 1. And so our graph will look like this. It just got shifted over 1 unit to the left. And then the next one even is, what are we going to do here? Well, this has a -3 outside of the exponential, so this is going to go down 3. So we're going to move all those points down 3. I'm going to go ahead and put those points here again. There's our 0, 1, 1, 2, and -1, 1/2. Here would be our parent function. So we're going to move all those down 3. So we got half to -half to -1.5 to -2.5. So that one moves down 3. And this one moves down 3 to -2. This one moves down 3 to -1. Our asymptote moves down 3 to -3. And so our graph would look like this. This one's pretty rough looking. Maybe I should have realigned my graph onto the grid in the background, but I didn't. So there is y equals 2 to the x minus 3. All right, 13 and 15 says write an exponential equation, a of t, modeling each account balance after t years. Well, this is exponential growth. It's compound interest. So we learned that compound interest, the amount after t years, is equal to your original amount. So we say a sub 0. Sometimes we just call this principal, times 1 plus our interest rate over how many payments per year. So n is the number of payments per year, and that whole thing to the number of payments per year times the number of years. So we might see a sub 0 or t or p. That represents our original amount. So that's the original investment. And sometimes this is a loan, so it might be the original amount of the loan. R is the interest rate. So it's in a percentage. We want to put it as a decimal. N is the number of payments per year. So if it's quarterly, that's 4 payments per year. Annually is just 1 payment per year. Monthly is 12 payments per year. Daily is 365 payments per year. And then T is just the time in years, which can sometimes be tricky if it gives you like half a year or 6 months. It's not that tricky. 6 months is half a year. So here we go. All we have to do now that we have that formula is just fill things in. So for number 13, $10,000, well, that's your A of 0 or your P. It's your original compounded. This is our rate, which we'll put as 0.06. And it's compounded annually. That means n equals 1. So our formula will be A of t equals our original amount, 10,000, it's a comma, times 1 plus 0.06 over 1 times t. Well, we can write that a little bit better. A of t equals 10,000. This we can add. This is just 0.06. So we have 1.06 to the t power. And then for the next one, we won't be able to simplify it down that much because we have monthly. So this is our A sub 0 or P compounded monthly. That means there's 12 payments per year, so n equals 12. This is our rate, which we move the decimal over twice. We change it to a decimal, so that's going to be 0.036. And so we can just fill this in. A of t equals 5,000, our original amount, 1 plus 0.036 over 12 to the 12t power. We can do a little simplifying here. If we take 0.036 and divide it by 12, that's going to be 0.003. If you need to get a calculator out for that, that's fine. So we can have 0.036 divided by 12. And then we add 1 to that. Obviously, that's 1.003 to the 12t power. And that is the formula for $5,000 compounded monthly at 3.6%. What this means, the assignment's finished, but what this means is, let's say you're able to put this away for some reason. You were able to get a hold of $5,000 when you're like 18 years old. You put it away and you want to save it for your kids' college. Maybe in 20 years, you could put 20 in here for T, and you could find out how much you have after 20 years. So a little bit extra. Let's try this out. It's pretty easy to just type into a calculator. A of 20 is going to equal, let's bring that calculator back out. So what we're going to do is we're going to have 5,000, not 0, 5,000 times, so parentheses, 1 point, not working right here, 1.003 to the 12 times 20. Well, will we really have Oops, okay, I see. I just put times, not raised to the power of. 5,000 times 1.003 to the power of 12 times 20. There we go. So that would have doubled in those 20 years and become $10,000 to $10,261. Anyway, that wasn't part of the assignment. I just wanted you to see what that meant.